Alright, so we now move on to graphing of the sine function, and we're obviously going to be graphing our transformed sine function. So, before we can graph, we need to know what the 6 steps for graphing are. So the first one is to find the parameters hk, little a, big A, and the difference between little a and big A is that little a is your parameter a, and you can get that directly from your function, whereas the big A is your amplitude, and this would be from the absolute value of parameter A. And then we have our parameter B, and we get our period by using 2 pi divided by your absolute value of B. For step number 2, we now find our starting point, which we said was at h and k. Step number 3, we're going to be drawing a rectangle with the height that is equal to 2 times the amplitude, and the length is going to be equal to your period. The fourth step in graphing is going to be to find the halfway and the quarter points. Now, if a times b is going to be greater than 0, the function is going to be increasing, whereas if a times b is less than 0, your function will be initially decreasing. And for our 6th step, we're just going to have to draw one cycle in the box. So these steps may seem pretty in-depth, pretty complicated, but they're actually fairly easy. As long as we follow them step by step, we should not have any problems at all to graph. So we're going to move on right away to our first example, and you might recognize this question already. This is where we ended off the last video, where I asked what this function would look like. And we said there would be a phase shift of pi to the right and 3 vertical. So finding all our parameters, we get h is equal to pi, k is equal to 3, little a is equal to 1, and in this case, big A, our amplitude, is also equal to 1. Parameter b is also 1, and our period is 2 pi, because 2 pi divided by 1 will be 2 pi. Looking at a times b, we realize that it's increasing at first because it's going to be positive. So a times b is greater than 0 in this case. So your next step would be to plot that hk, and in this case hk is pi and 3. So once we have that down, we draw our halfway line on that point, and that's basically going to help us orient ourselves as we start using this Cartesian plane to graph. So the next step is to draw that box. Now, how long do I need to make this box? Well, we said the length of this box is going to be equal to your period. So if I'm starting at pi and I add 2 pi, I end up at 3 pi. So the length of my box will end at 3 pi. How do I know how high to draw this box, or how low to draw it? Well, your amplitude is going to be 1 in each direction. So 1 above and 1 below. So this is the box that you end up forming, your rectangle on your Cartesian plane. Now, we also know that since we're beginning at pi and 3, we're also going to be ending when the box ends at the same height. So that means that my halfway point is going to be at 2 pi and 3, because my final point is at 3 pi and 3. Once I have my halfway point, then I just need to find my quarter points. Now, my quarter points are going to be found halfway between your initial point and your halfway point, and then halfway from your halfway point to your final point. So my first quarter point is going to be somewhere either at the top of the box or at the bottom of the box. And how do I know where? Well, basically you look at a times b. Since it's initially increasing, my point needs to be at the top. And then we know that we're definitely going to be decreasing eventually, so the second point in this case would be at the bottom. So your graph, this would be representing one cycle of it, and all you need to do is connect these dots in a curve manner. So in other words, this is what your graph will look like in the box. Now what I've done is I've extended it backwards and frontwards using the mathematical software, and this is just showing you that even if you just draw this cycle, that's correct, but this function continues forever unless I restrict its domain. Moving on to the next example, we now get the graph of y is equal to negative 2 sine pi over 4, x minus 1 plus 1. So again, we need to figure out what the parameters are in this case, and our h and our k are 1 and 1. We then look at the value of A, which is -2, so the amplitude in this case would be 2. We then continue by looking at B, and B is pi over 4. So therefore the period is going to be 2 pi divided by pi over 4, which will give us a value of 8. Now the last thing I need to look at is what is the value of A times B? Well, in this case, the value of A times B is less than 0 because I have a negative number and a positive number that are being multiplied, so it will be negative. Therefore, my function will be initially decreasing. So this is going to be very important when we actually start drawing our graph. So the first thing we want to do is plot that HK point and put that halfway line, which is exactly there on our graph. It's at 1, 1, and I draw that horizontal line. I then say, okay, well, I need to know what the length of my box is, and the length is going to be equal to your P, which is your period. So if your period is 8, and I'm starting at 1, I know that my box is going to end at the value of 9. Now, how do I know to draw my box 2 above and 2 below? Well, that's by looking at the amplitude. My amplitude is 2, which means that if I'm starting at 1, I now end up at 3. And if I started at 1, I end up at -1. So I put in my halfway point and my final point. So my final point is going to be at 9, 1. So my halfway point is going to be at 5, 1. I then need to look at my quarter points. So I know my quarter point is going to happen when I have the x value of 3, because that's halfway between 1 and 5. But is it going to be at the top of my rectangle or below, at the bottom? Well, let's look at A times B. Since it's negative in this case, initially my function is going to be decreasing. So my first quarter point will be at the bottom of the box, which means that the second quarter point will be at the top of the box. Now, once I have these points all over in the box, I'm able to connect those dots with a curve. And if I were to connect them, this is what my function will look like. Now, again, I've extended the function to the right and to the left just to show you that when the domain is not restricted, your function has a domain of all real numbers. So it continues on both sides. But what do we actually need to graph? What is the most important thing here to graph? Is our function in our cycle. So in this box that you've actually put. Now let's not get confused. This box is not part of your graph. The only thing that's part of the sinusoidal function is, in reality, this curve that's going through the box. So the box is not really part of your graph. Alright, so moving on to example number 3, we now get something a little bit more complicated, but still very easy to deal with. And we now get y is equal to -2 sine. And we have this pi x over 3 plus 2 pi minus 3. So the first step in this case is going to be to factor out something from the inside of that parentheses. And what do I need to factor out? Well, pi over 3. So once I factor out pi over 3, I now get a value of 6 inside. And the reason I have that is because I did 2 pi divided by pi over 3 to give me a value of 6. I now list all of my parameters. My h is -6 in this case because there's a positive inside the brackets. And k is -3. I also end up with a is -2, so my amplitude is 2. The b is pi over 3, so my period is going to be 6 in this case. And a times b is again less than 0 because I have a negative number multiplying with a positive number, which is negative. So if I were to start graphing this, I plot my h and k, which would be at -6 and -3. Then from there, I put in that halfway point. Now again, if you look on the y-axis, I just shifted down this -3 so that we're able to see properly. So this line represents -3, and this would be your -4. All right? And I could then draw my box, which has a period of 6. So that means it ends at the y-axis line. And then from there, I start putting in my halfway point and my quarter points. So my halfway point in this case will be at a value of -3. My quarter points, well, because I'm decreasing at first, I need to put my point at the bottom of the box, and then the next quarter point will be at the top of the box, which will be found halfway between the halfway and the first point and final point. And when I graph this with my graphing software, this is what my function looks like.